Hello, everyone. So it's my great pleasure to be the very first that's gonna present for this year's AsyncAPI conference. I'm gonna talk about the future of AsyncAPI and more specifically about the version 3 that we are working on. Now, whether you're watching this live or watching a recording later, I hope you're having a fantastic day so far, regardless of whether it's morning or evening where you are. Now, before jumping into it, I just want to say that I am just the humble messenger here. Um, these changes are provided by the champions of the async API specification. So this means that we have individual contributors that are pushing these changes forward and spending their time in order to make this ecosystem as best as it possibly can. So just want to say very big thank you to you. Throughout this presentation, I'm going to have these types of links to the discussions that we have and the issues that I'm talking about. I'm going to provide it in the bottom left side of the screen, which I can see my name is hovering over. So let's see how much you can see, but I wanted to give you, I'm gonna make these presentation slides public as well after this. But yeah, all of these issues are something that you can access through this link. Throughout this presentation, I'm also going to use an example application that we have defined with AsyncAPI to show how these changes are affecting the spec itself and the documents that you create. So in this case, we have a very simple account service, which is in charge of processing user signups. Very simple. And it does this by interacting over this user signed up channel where it says that, well, others are publishing to this channel because we are consuming from it or subscribing to it. And these are, or this is the message that we expect to receive. And this user sign up message is just a very, very simple payload, which is an object which has two optional properties, just a simple display name and email, just for the purpose of this demonstration. Now, it's of course almost impossible for me to do or to introduce all of the changes that, or even all of the discussions that we had. So all of these are mainly just a highlight of the different improvements that we are trying to make and the different problems that we're trying to solve. The first one I'm going to introduce is this publish and subscribe confusion, which you probably already saw in this last example, where you kind of define the operation from the opposite perspective of how others interact with your application. So in the case of our account service, this was that others are publishing to this channel with the following message because we are subscribing to it. That's the pub-sub confusion that we're trying to solve. Then we have some reusability improvements in terms of channels. There's kind of two things, channels and schemas, and how those are reused across multiple async API documents. Third, we have request response pattern, which I don't think it's an understatement if I say that this is the most widely requested feature within async API. Then I'm going to talk a little bit about references and message payload, because we in async API, we really want to enable you to use any schema format in order to specify the message payload. This means it can be JSON schema, but more specifically, we want to also enable you to use non-JSON schema files, such as protobuf, XSD, to describe your payloads. So it all depends on the ecosystem that you're in. And lastly, I'm just going to quickly touch upon the tooling mentality and how we are trying to change the mentality around tooling and minimize how much effect a breaking change in the spec has on tooling. So we minimize this ripple effect as much as possible. But let's start off with the publish and subscribe confusion. Now, the problem comes from this very simple question that if you're trying to use AsyncAPI to define what, or for example, in this case, how do you define that an application subscribes or consumes from a certain channel? If we take a look at our example AsyncAPI document, you can see that this publish operation, which is where everything or this whole confusion comes from, is that, well, publish operation defines the messages consumed by the application and not what the application does in its terms of behavior. And this can be very confusing, especially in event-driven architectures where this client perspective, that's not something you have. You have it in REST and you have it in WebSockets, for example. But in other broker-based architectures, you don't have that client perspective, and it creates a bunch of confusion. So the proposed solution for this, and the way that we are trying to solve it, is that instead of saying this API perspective where you define how others interact with you or your application, we change this to a behavior type definition that says, well, how do I interact with others? What is my behavior, my application's behavior? So let's take a look at them. And the way that we want to do this is by simply changing the operation keywords in a very simple form. So this means that an application that wants to send certain data to someone or over a specific channel is, well, it's instead of subscribing, it's using this send keyword. So you are sending to someone else. Then we have, for our case, with the account service that is in charge of processing these user sign up. Instead of having this publish operation keyword, we use receive because the account service is receiving over this channel. It's receiving this user signed up message. And yeah, this means for an external application, if you want to define that others, that if you want an external application, how others are interacting with your system, you can, for example, say that, well, this external application is in charge of signing up users, and it's sending this user signed up message to the user signed up channel. And that is the very, very basic terms of how it's currently looking like it's going to change. Then I'm going to talk a little bit about reusability improvements. And the very first one we're going to look at is channels. So in AsyncAPI, if you have two AsyncAPI documents, one for each application, one for the account service that is processing the user sign up, and then, for example, a website backend that allows users to sign up, we then have these two definitions where it's not possible to reuse this channel between the two applications because this operation keyword is kind of in the way, because that is different from application to application depending on their behavior. So in order to solve this, we're looking at two possible changes. The first one is that instead of having the channels defined using the address as key in this map, we just have an ID for the channel. And then we introduce this address keyword, which then contains the channel path or the topic, depending on your system, how you want to interpret it, that you can then use these in order to reuse them across multiple documents, which I'm going to show a little bit later. The second one is that we want to completely disconnect the operation keywords and which operations an application performs to its very own root object called operations. This means that, for example, for the user signed up or the processing of the user sign up messages, we have this action received, which then just reference the channel that it's operating over called user sign up. And now we have it completely detached from one another. And this means that if you have these two applications again, you can now reference the entire definition of what a channel is across these two documents or those two applications and use the very same definition. And of course, we then have for each of these applications, we of course have two very distinct operations that are just both of them operate over the very same topic or channel. We're also looking at whether we can improve the UX a little bit, whether it is necessary, let me go back, whether it's necessary for applications to define which channels they operate over, or whether we can skip that whole process and just let the operations reference that external document that they both of these applications share. The second improvement is schemas and formats. In AsyncAPI, or we want to solve two problems. The first one is that it's not possible to define schemas of other formats within the component section of the AsyncAPI document. And the reason this is because, well, it's messages that has this schema format keyword that defines what the schema format actually is. This means that once you make this reference, that information is completely lost. So if you have two messages that both reference the very same payload, it would both have to define this schema format in order for the reference to work correctly. The second one is that it's not possible to properly define, and this is the core problem in a sense, that it's not possible to properly define a schema and its format within a self-contained object. So for example, even if you don't think you're using schema format, this keyword, by default, this is the exact value that any message is using. So unless you overwrite this, this would be the value for it. So for example, let's say that we use Avro, and instead of having this AsyncAPI schema object to define the message payload, we use something like Avro. Now, just quickly, Avro is a serialization system, so you define the message type instead of validation rules that you do with JSON schema. But as you see here, it's not now schemas that's within the component section. It has no information that this user sign-up payload is described using the schema format keyword or this Avro schema format. So what we are looking at is, well, what if we just move this schema format keyword from the message object and move it down to schemas? In order to, whenever you reference something like schemas, it already have the information about, well, what format is it? And we also, of course, then tells it or just inlines the very schema itself. And this enables you to reuse these. Let's say that you have two messages, just a simple example where you have two user signed up messages that both reference to the same schema as a payload. Well, now you don't have to duplicate the schema format value in any of the cases. And this means that the entire schema object is a self-contained object that everyone can reference without having to also have this duplicate data. Then we have request and response pattern. We are looking at 4 different use cases. And those are the main ones that we are focusing on. The first one is, how do you define a request response pattern where you have a predefined response topic? So at design time, whenever you design the behavior of the application, you can predefine to which topic that the response is returned to. Then we also have something like dynamic response topics and a new response topic per reply for each reply message or for each request. And these use cases are for if the underlying protocol, for example, where the response topic is purely dynamical and are something that is not resolved or defined before that you actually send the request. For example, in Nats, by default, everything is dynamically created. So when you make a request over a certain topic, that Nats then automatically creates this reply topic for you and subscribes you to that topic. So everything it handles natively within Nats there. But then we're also looking at WebSockets, for example, because WebSockets is a little bit different than most, because everything runs over the very same channel. All the messages runs over the root channel, and there's no segregation in any form. So there you only have access to something like a correlation ID or reply topic ID. So let's look at a very basic example. For example, a ping and a pong. So I'm sending a ping and I expect a pong response. The way that this can be described, or that we are suggesting, is that, well, you then have these 2 kinds of operations. We have the initiator of the ping, which is that you take the action of sending the ping message over the following ping channel. Then you define the reply channel that you expect a reply to come back to, which is the pong channel. You can then also have the opposite side, of course, which is, well, I am receiving a request and I am expecting to send a response in return. And in these cases, we then just switch the action to be a receive. So we receive a message over the ping channel, and then we reply with the pong or over the pong channel. Then we have these dynamic at runtime creation topics. And we're looking at, well, what if we just have these address null types, where instead of having a well-defined topic that the response gets back to, it's null or undefined in a sense until you reach the runtime. Yes, and this is still highly work in progress. We're still discussing this, and there's nothing that has been merged within the spec itself yet regarding this, but it is underway. Next up is references and message payloads, and that's how can we enable you to reference non-JSON formats for the message payload, such as XSD schemas or protobuf schemas. And this is it's a problem because there's no standard that properly define this behavior. There's no standard that we can say, well, we just use in our case, in 2.5, we use JSON schema, JSON reference standard. But that JSON reference standard is, well, as I read it, mainly about referencing to JSON data. So the way that we're looking at changing this is kind of in 2 ways. The first one is, or the first possible option is that Well, what if we try and solve this problem in a more common manner across specifications such as JSON schema and OpenAPI and AsyncAPI, of course, because we all use the JSON format and we all use this reference keyword. So it would make everything a lot easier, even in tooling, if we all reference the same standard. So this is what the JSON community is mainly trying to push forward here. So I highly recommend you to check this out. The second option is that we try to solve it locally only for AsyncAPI. And of course, there's a couple of ways of doing this. But one way could be, for example, to make an extension to the already existing standard that we use, which is JSON reference, and just enable us to link to non-JSON data. But this is highly work in progress and it's not easy at all. But it is something that we're looking at and spending quite a few hours on. Lastly, I want to talk about tooling mentality, or more specifically, how can we minimize the breaking changes impact on tooling? For example, if you're used to OpenAPI and its tooling system, for example, whenever a new major version comes out, or even a minor version, some tools don't even support it. And that's because it takes time and effort to maintain a tool that evolve over time, where the underlying standard evolve over time. So we need to try and take a look at how can we minimize the impact of breaking changes. And the way that we're going to do that is for something that we call an intent API. So in the very, very basic form, it's you have certain intents whenever you try to interact with your async API document in tooling. That means, for example, it could be, or let's just take a use case that's not async API, for example. In this case, it's buy 5 watermelons. Well, what does that entail? Well, that's the intent, but underneath everything, it's, well, I have to go to the fruit shop or some other shop. I need to grab 5 watermelons. Then I need to go and pay for them, put it in a bag, exit the shop, go home. That's everything that's happening, but our intent is just to buy 5 watermelons. So the way that we are kind of looking at it in terms of intents is that we mapped all of the interactions with all of the tools that we currently have within the Async API organization. And then we tried to map all of these intents and then split them out into certain API calls. For example, the intent could be get all operations my application performs. And in the very simple terms, it's just saying the async API document dot operations. Done. Now, internally within the parser, depending on whether it's version 2 or 3, we then, well, in version 2, we have to iterate over all the channels and grabbing all of the operations in there. In version 3, we, as we saw before, it could, for example, be iterating over all of the operations that there is in the root object. And that is the very, very basic terms of what we are trying to accomplish. Of course, we cannot really guard ourselves against every breaking change, because let's say that we change the entire or the core type, for example, for descriptions, instead of a string, let's say that we want to include it as an object that can have multiple languages. For example, we have a description for English, we have a description for Danish, Spanish, Polish, whatever. Polish, sorry. And that core type now changes from a simple string to an object. That's kind of impossible for the intent API to guard against. But other than that, the structural changes, how and where information is located, that should be possible to guard. But this is a highly work in progress as well. But yeah, that's the core changes that I wanted to introduce. So we looked at how we can make it easier to reuse certain sections of the async API document. We saw about how we can solve this publish and subscribe confusion. Then the change of enabling request response patterns and enabling the use of non-JSON formats such as XSD and protobuf. And in the end, making breaking changes in the spec less impactful for tooling. And in some cases, you don't even have to update the tool. All you have to do is update the dependency to the parsing library. And as a final note, feel free to join us. We have our public bi-weekly meeting that only revolves around version 3. That's happening each Wednesday at 4 p.m. UTC. And it's happening this Wednesday next week. And just to emphasize, we are a friendly bunch of people that just loves open source, and we are more than we are more than willing to help you take your first step in the open source world. Other than that, thanks for your attention, and